The ready for lesson 2.9 is a whole lot like a Punnett square in biology, and it's going to let us set up multiplying binomials a lot more efficiently. So for number 1, we have 3x and we have a minus 4. We have 7x and we have a minus 5. So it's a matter of multiplying. Taking a look at what is on the left, multiplying it in. What is on the top, multiplying it down. So when you do that, just to clear those arrows out for clarity's sake, 7 times 3 is 21. X times x is x squared. 7x times negative 4 is negative 28x. Negative 5 times 3x is negative 15x. And negative 5 times negative 4 is positive 20. Just like any of these lessons, please, if you get stuck, pause it, go back to it. So now it's a matter of combining like terms. You have 21x squared. The minus 15x and minus 28x would end up giving us negative 43x. And negative 5 times negative 4 is a positive 20. For number 3, same process. And you're going to see this for each of them. Same exact process. Take 4x minus 3, 3x plus 11, and multiply. 3x times 4x is 12, x squared. 3x times negative 3 is negative 9x. And 4x times 11 is 44x. 11 times negative 3 is negative 33. We're going to combine our like terms, and when we do that, we end up with 12x squared plus 35x minus 33. Number 5, same process. 3x minus 10, 3x plus 10. 3x times 3x gives me 9x squared. 3x times negative 10 is negative 30x. 3x times positive 10 is positive 30x. And positive 10 times negative 10 is negative 100. We'll combine our like terms. And when you do that, 30x minus 30x ends up giving me 0. So we would have 9x squared minus 100. It's not plus x or plus 0x or minus x. Just leave it as 9x minus 100. For number 7, once again, same process. 4x plus 5. And this squared, all that means is that we're doing this twice. We're multiplying it by itself. So 4x plus 5 again gives me 16x squared plus 20x plus 20x here and plus 25. We'll circle and then combine our like terms. And when we do that, we end up with 16x squared plus 40x plus 25. For number 9, one more time, it's the same process. 10x minus 7, 10x minus 7, and we multiply. We will combine our like terms. And you should end up with 100x squared minus 140x plus 49. For the set portion, I'll do a few of these just to get you going and then show you how you can confirm what it is that you're trying to do. For number 11 through 19, we're looking at factored form and being able to make some observations from that. The first of which is the X-Intercepts. And I'm going there just because it's going to be much easier for me to be able to identify the vertex once I have the X-Intercepts. So the X-Intercepts are going to be what make the interior parts of the parentheses 0. Well, if I plug in a 2 into the first parentheses, I would get 0. So 2 comma 0. And then if I plug in a -6, it would also get me 0. So now the big thing here is, what is the halfway point between -6 and +2? And if you were to set up a number line, you would have -6, -5, -4, -3, -2, -1, 0, 1, 2. I need to figure out the halfway point between these two. There's 1, 2, 3, 4, 5, 6, 7, 8. So halfway would be 4. Would be right here. And that would be -2. So I know that the halfway point would be -2. My axis of symmetry would be -2. Once I know that, I can plug it back into my equation to find the y value, and that is my vertex. So 4 times -2 minus 2 times -2 plus 6 so you would end up with -64 as your vertex. The y-intercept, we can take that and plug 0 in for y, and then solve our equation. Sorry. We can plug 0 in for x, and it will give us our y-intercept. Knew something looked weird there. So y equals 4 times 0 minus 2 times 0 plus 6. 4 times -2 times 6 would give us -8 times 6, which is -48. So it'd be 0, comma, -48. The stretch is what is in front of the parentheses. Okay. It'd be 4. Number 13, same process. So the X-intercepts first, we're going to plug in these values to try to get the inside of the parentheses equal to 0. When you do that, you would end up with -5, 0, and -7, 0. Now the halfway point between -5 and -7 is actually -6. So you know you've got your vertex there. And then plugging it in, -6 plus 5, -6 plus 7, that would be -1 times +1, which means that my vertex is at -6, comma, -1. For the y-intercept, plug it in 0. Five times 7 is 35. And the stretch, you'll notice, out in front there, there's nothing, which means that we can multiply it by that place holding 1, and there you go. For number 15, same process. And I'll clear out some space here. Find your X-intercepts first. 8, 0, -4, 0. Halfway between 8 and -4 would be 6 units. So we know that 2, plug in the 2, and we would have negative 1/2 times 2 minus 8 times 2 plus 4. So negative 1/2 times negative 6 times positive 6. That would be 3 times 6, which would give me 18. The y-intercept, negative 1/2 times 0 minus 8 times 0 plus 4. Negative 1/2 times negative 8 times positive 4 would get me a positive 16. And the stretch here, again, looking at what's in front of my equation here, would be negative 1/2. I'd be stretching it wide and pointing down, as opposed to the parent function. One more here, because this is just that much fun. Number 17, X-Intercepts, 3, 0, and negative 3, 0. Halfway between negative 3 and positive 3 is 0. So I plug in 0 and see what happens. Well, 3/4 times negative 3 times positive 3 gives me negative 27/4. Man, that's a bummer. Lots of stuff to work with, and fractions are not going away. What else is cool is that that's our y-intercept, 0, negative 27/4. And your stretch, once again, is the part that's hanging out in front of the equation. Now, what I would like to encourage you to do is to use resources wisely. Going off the beaten path a little bit, you can go to desmos.com/calculator, and if you type in, let me just type in one that I didn't do for you, number 14, half x minus 7, x minus 7, you can type in y equals 1/2 x minus 7 times x minus 7, and you can see what's going on there. Oh, I only have one x-intercept, and if I zoom out, I see that I have 0, 24.5 is my y-intercept. I can see my axis of symmetry is right where this is going to split down the middle. Okay, you can see your axis of symmetry would be right here. And you already know your vertical stretch is 1/2, so it's going to be a little bit wider than normal. Then your parent function, you have everything that you need just by typing it into Desmos. Now, you may have to back out of it, and like I did, or zoom in to be able to get the right scale. But it really does a good job of setting this up for us. And I say that knowing that you also have the Go portion, which is asking you to use Vertex Form now. So using what we know about Vertex Form, well, Vertex is just saying what's going to make this create the whole interior of the parentheses to be 0. So that would be negative 2. And then what's outside? Negative 4. There you go. For the X-intercepts, I would strongly encourage you to lean on Desmos for this, being able to graph it and identify the points for which you can see we have an X-intercept. For the Y-intercept, we can plug in 0 And we would see that, we would have 0, 0 as our y-intercept, and the stretch would be 1. Okay. For number 22, same process. For the vertex, plug something in that's going to make the interior of the parentheses 0, 1. Once it becomes 0, everything here becomes 0, and you're left with minus 8. For the y-intercept, plug in 0. And you would end up getting 2 minus 8, which is negative 6. And your stretch here is talking about that piece out in front of the equation. And there you go. For your X-intercepts, I want to make sure that you get a chance to go in, put things into Desmos, and be able to see what's happening. Number 24, the final one that I'll do here. Same process. 2, 48 would be your vertex because I'm plugging 2 in here. Zeroes it out to the left of the addition sign. 48 remains. For the y-intercept, negative 3 times 0 minus 2 squared plus 48. Negative 3 times positive 4. Negative 12. We would end up with 36. So 0, 36. And your stretch is negative 3. Hopefully this helps. Again, lean on Desmos as much as you can, as needed. Have a great day.